All right, sounds good. Welcome, everyone. I'm Damon Monty with Excessive Services at the IDS. I'm current president of the Engineers Association. I hope you're all doing well coming into the holiday season. The good news is that just over 3 weeks, we can begin to forget the year that was 2020. I'm looking forward to a brighter new year. So I've got a couple announcements. BOMA is pleased to announce the latest launch of online self-paced courses now available for all courses required for your SMA or SMT learners. If you're interested in achieving your certificate or designation, visit the BOMA's website for more information. Get your team registered for the virtual holiday party next Thursday, December 17th. You'll have a chance to connect with fellow BOMA members and win some prizes. You must be registered by this Friday to receive your gift. So our next engineer meeting will be held virtually January 6th, and the presentation will be the new chiller technology. Registration will open next week. So now I'd like to introduce today's speaker, Bob French, Chief Evangelist with 75F. His mission with the company since 2014 has been to make commercial buildings more efficient, comfortable, and healthy. He leads the business development team for the Americas. Bob is also an entrepreneur in residence at University of Minnesota's Carlson School of Business, where he mentors business students and startups. Bob, we appreciate you taking time to present to our Engineers Association today. And with that, I'll toss it over to you.
Yeah, thank you very much, Damon. I'm just going to share a screen here also and kind of get started. Before we get started with this topic, we do have a couple of poll questions I'd like to ask just to help me get a better sense of who's attending today. So Riley, could you throw those up for us? This first one is to help me understand, what role you're in. So what best describes you? And we'll just wait a few minutes here until we get this in. We kind of took a guess before we got started. We thought maybe 3/4 would be building engineers. So I'm kind of curious to see how the numbers actually pan out in the end. Yeah, it looks like we settled out there. I think you can end the polling on that one. And we just have one more question. This next question has to do will help us understand how familiar you are, or how often you use a BMS. And we just put the question here. I'm using it every day. If you're using yes, once a week or whatever, just answer no. That'll help us understand how interactive and how familiar you are with BMSs. Well, that's looking pretty good. Looks like that is settled out. Doesn't take that much time. Thank you very much, Riley, for that. Looks like 3/4 are using a BMS on a daily basis, which is awesome. So I think that I just close it out like that. Great. Okay, so first I just wanted to go over some definitions. EMS, BAS, BMS, IoT, BIS. We see a lot of this, I call it alphabet soup. So I thought that I would just take a moment to give what I think are some commonly accepted definitions of what these things actually mean. And that'll help us as we go forward. So I think probably the oldest term in the business is energy management system. And this is a system that is generally designed to achieve energy efficiency through process optimization and reporting of granular energy use. A case in point would be, let's just call it a connected thermostat. A thermostat that is connected to a network, usually it's a Wi-Fi, and that thermostat can be used to set points for buildings, set the occupied versus unoccupied schedule, which can achieve a setback, right? Those are the things that an energy management system do. And the reporting usually is a pretty big part of it, meaning that you'll be able to see a report of consumption, and generally reports that show and compare and contrast one system or one site versus another. You probably have one of these at home. If you have an Ecobee or a Nest thermostat, I mean, if you think about it, that's really a kind of energy management system. When used in commercial applications where there's a lot of buildings, and it's just that, times however many sites there are, however many devices that there are. Moving up from there, we have the term BAS or BMS, building automation or building management system. Those two terms, in my opinion, are interchangeable. But this is where we're actually controlling and monitoring the building's mechanical and electrical equipment with automation. That's a key differentiator with an energy management system. A BAS or BMS is needed in the more complex building. I mean, if you have a simple building that really just has, single or dual set point devices like rooftop units or heat pumps, that kind of thing, an EMS can do most of what you want. But as soon as you get into a building with any kind of zoning or a central plant, you have to have a BMS to help institute the sequences of operation that are needed, like a VAV, the most common type of zoning system, or even a hydronic building, one with water source heat pumps or 2 or 4 pipe fan coils. Even though each of those terminal units is a single or dual set point, they do require hot and chill water from a central plant. And so there's some degree of building automation there. Some newer terms that I wanted to talk about is IoT, which is the Internet of Things. This has been around, the idea has been around for about 20 years. I've been involved in IoT for most of my career. We didn't call it IoT back in the 90s, when I was working with web systems, e-commerce, catalog systems, that kind of thing. But it was very similar. We had remotely connected kiosks, for example, in the mid-90s that I was dealing with. So later on, that idea started to be called the Internet of Things. But the key difference is that we have the insertion of the cloud or the internet that is very closely tied to each of the devices. So the devices are embedded. There's sensors, there's firmware, software, that's all designed to bring data together and to tie the cloud in to make the power of the decision making, much greater. In fact, infinitely greater. And so there is a term that is starting to emerge now, a building intelligence system, which is really, I think of it as a BMS that is accomplished with IoT. So you get artificial intelligence or machine learning that can be now integrated, because in the old world, you were limited to whatever the workstation computer was in the building. As soon as you connect it to the cloud, you can bring in a lot more power. So machine learning, artificial intelligence, cloud computing, big data. Again, it's another alphabet soup of all that stuff, but the concept is that the web enables us to do things that just couldn't be done before. So let's just review quickly what your traditional BMS looks like. I'm sure that all of you who are using a BMS even weekly understand these ideas. You have a hierarchy and a network. You've got your devices, your field controllers, which are managed in groups, and then some kind of a supervisor right? So as soon as you bring the cloud in, you get different capabilities. So I'm sure you've heard the term edge, right? Or edge computing, or the edge of the network. What we're referring to there is essentially the devices, the device level. We're talking about the end of the line. If you have a network which has gone through that hierarchy that I just described, down at the end, you know, the last bit of connection, you have a device that's doing something. We call that the edge. And we need to be a lot smarter at the edge, because this is where, you know, all of the energy is consumed. And it is also where people are either made to be comfortable or uncomfortable. And it's also where people are either getting healthy air or unhealthy air. So this is, you know, where the pedal, you know, hits the metal, for example. So, I mean, I'm thinking of optimized economizers, you know, EC motors, advanced rooftop controls, right? So there are things that are possible now at the edge, which just aren't really practical to put into a traditional BMS. There's just too many points, right? Because in the traditional BMS, the cost of the BMS is directly related to the number of points that there are. And so nowadays with IoT, the need and access to points is just so much greater. So that is what, you know, calls for a new architecture. So if you just take that same idea, that same sort of hierarchy, but you add the cloud to it, you know, you get the Internet of Things, and you can get artificial intelligence and machine learning. So this is a key change that has been evolving steadily over the past 10 years. And that also brings out, you know, as it has been advancing, there are new needs that come forth. Like Project Haystack, for example, is a industry standard for IoT, and the majority of what they're doing is HVAC and building automation related, because that's where the biggest need is. And so ASHRAE's BACnet committee, you know, there is some work going on, you know, 223P, which is an effort to gain a semantic tagging of building data. And what I mean by semantic tagging, really semantics is really just language, right? If there weren't some kind of a standard, a common language that systems spoke, everybody would go off and do their own thing, and then there would be, you know, a lot of effort that needs to go into integrating. But if everybody's speaking the same language, it becomes much easier for systems to work together. And that's what Project Haystack is all about. And BRIC and, you know, as I said, BACnet is working on this, the BACnet committee for ASHRAE. So I'm just putting this up. Obviously, you can do, you know, if this topic interests you, you can dig further into what ASHRAE's BACnet committee is doing and what Project Haystack is all about. So why is that important to you in, you know, with your buildings? It's a sort of a revolutionary idea, but as soon as your building is not an island of information, as soon as it is connected to the internet and the data becomes a repository for that data, I'm sure you've heard the term digital twin. It is a way of replicating or making a digital model of a building that resides in the cloud. It enables us to bring other types of cloud systems to bear and to be integrated, you know, like GIS and assets, work orders, all kinds of things that are not traditionally held inside of a BMS, and they shouldn't be. You know, think of tenant billing, you know, for example. Tenant billing is a complex topic. And there are very different views on how a tenant should be billed for their consumption of heating and cooling, and different schemes, you know, for it. But the data that the BMS system actually manages is central to what kind of billing should happen, for example. And so there are a lot of other web-based tools that building owners and managers are using to help them run their business more efficiently. I know I'm just repeating myself here, but web computing and cloud computing is a standard and it's a fact of life for virtually all aspects of businesses now, right? You can't use software on your laptop anymore that doesn't have an annual or a monthly subscription. You can't just buy a copy of Photoshop, or you can't just get your accounting system. Instead, you pay for it as software as a service. So building owners are they're taking advantage of this and have access to much more powerful systems than they've ever had before. But now when you bring cloud computing in, or the IoT type of architecture, asset management and space management, capital planning, right? All of these things can then be informed by the data that your BMS is generating. So it's really kind of a paradigm shift in the role of the BMS in the industry. So we at 75F use an IoT-based architecture. This is how we've done it. So we have a couple of devices that we would consider to be, at the device layer. There's just two of them. One of them is geared towards being a thermostat for any sort of dual or single set point device. This stat is what you would put on a water source heat pump, a 2-pipe or a 4-pipe fan coil unit, a split system, an RTU, unit heater, baseboard radiators, all of those devices that you find in the terminal equipment list that can be controlled with a thermostat. We would use a single device for all of those. And the sequences of operation that are different, like a 2-pipe fan coil operates differently than a rooftop, for example, a package rooftop with heating and cooling, right? It's just not the same profile. But with IoT and software-defined hardware, you have a generic device that has multiple profiles built in that are able to handle those different sequences. While we're at it, going ahead and collecting a lot of other data, like CO2 and VOCs, occupancy with infrared, light levels, sound levels, supplier temperature, those things all inform the building operation as well. And so they're all built into a device like this. So they also are connected. They're not connected in a way that your traditional BMS is. These are connected with a 900 megahertz wireless mesh. That technology has advanced quite a lot over the years. The one that we use is not a industry open tool. It's one that we developed ourselves in the 900 megahertz frequency range to get really good performance to connect these devices automatically. And the goal there was to take the networking task out of the picture. So the whole goal for us was to develop a system that could go in very easily, that the programming and networking task would be reduced or eliminated, just so that we could get these systems in at a better value. The other device at a device level that we're talking about here is what we call a smart node. This is more of a generic I/O type of device with analog and digital relay I/O, and it's what we use for all the other terminal devices that are not controlled by a thermostat, like a VAV box, for example. We would put this controller on the VAV box, or any damper or VFD, or anything that needs to be scheduled. Boilers could be enabled, disabled, put on a schedule with outside air temperature reset, or like whatever is needed to be done. These are all done with this other device. This is all connected through the 900 megahertz wireless mesh also. And it also includes an RS-485 Modbus connection so that we can pull in data from all kinds of other equipment that we don't manufacture. So at the supervisory level for us, this is a device called the Central Control Unit. This is going to be supervising up to 48 of those other devices. And it is the gateway to the internet. So we need some kind of an internet connection at this device only. That could be a cellular or an Ethernet drop or Wi-Fi. Wi-Fi is the most common just because it's so easy and fast to do. But this is also a controlling device. It kind of plays different roles in the schema. It's going to control an air handler or a larger rooftop unit. And then it's going to get all that data up to the internet, which is where this is the portal, right? These are the mobile apps that you can use to monitor your building and change settings, with your smartphone or your desktop, laptop type of usage. This is where the interaction with those other systems comes to bear. I skipped one point about the CCU. It is also a BACnet IP server. So if we're ever working with some other type of BMS, all of the points that you find, coming from these two devices, right, they're all rolled up and gathered up by the CCU and then served as read-writable points through BACnet IP for a client that might be out there in the building already. Like one way that this might be done is you might have a BMS for your plant, and you might not want to change that, but you might be ready for putting a different, more modern system in the leased spaces. So you could put our devices in all the leased spaces and then get all that data in your BMS through this BACnet IP server. So the last point about all this is just to illustrate, how an IoT design system looks, different than your traditional BMS. The other thing about this is that there is the ability to field adjust the parameters that are used for the sequences, but we don't offer the ability to write new sequences, right? All the sequences in this system are out of the box. There are abilities to create custom sequences, and generally using another BMS might be a way of doing that. Like I was talking about earlier, how you might have a traditional BMS for your plant, which tends to be, complicated and custom, and unique, to every building. But the terminal equipment, the air handlers, VAV boxes, and so on, they're not unique, and they don't really require any programming that we haven't already, programmed. So that's what we mean by out of the box. So the last thing I wanted to mention regarding the way we've done things is that we've created an API. This is a modern service-oriented API, which your development people would understand instantly what that means. And it means that we create an interoperability it's new, right? And for the BMS world, the entirety of our system is open through this API structure. And this enables, remember in that slide I was showing you a few minutes ago about how there are other web-based systems like asset management, for example, those systems can then be deeply integrated with our system through an API like this. So honestly, this is new enough that there aren't very many examples of where this is even being used, but I'm sure that your mind is turning about applications that could be accomplished using this kind of capability. Now, I also wanted to mention that this year, as Damon had mentioned, 2020 has been a heck of a year. The COVID-19 is just throwing everybody on their ear, and we of course have been very involved in that because in HVAC, ventilation is turning out to be a key to COVID-19 mitigation, because it is an airborne illness. The way that you operate the ventilation in your building has so much to do with the transmission rate. And I think it's been pretty well studied now that it's an airborne illness, that the transmission is airborne, and that if you can reduce the concentration of the virus in the air, in the enclosed spaces, we don't have any trouble outside, but inside, where it's enclosed and we have ventilation, we need to operate our ventilation system very differently than before. Now, I'm relieved that there's talk of a vaccine. It's coming out soon. The numbers are looking really good. But I think everyone sees that it's going to take many, many months for the vaccine to take its effect. And I think there is a bit of a tendency right now for people to start relaxing a bit, to say the vaccine is coming, the pandemic is going to be over, we're going to be through this. But if you're a building engineer, I would like for you to think differently. I think that the effect of COVID-19 and how devastating it has been is something that will affect your job for the rest of your life, because there will be another pandemic. And this airborne transmission seems to be a huge vulnerability. Our building standards, our design standards have not accounted for a pandemic. I want to move on to what ASHRAE says about this. If you haven't visited the COVID-19 pages at ASHRAE, I really recommend you come up here and start with this page. This is the Epidemic Task Force. And this section here in the middle about building readiness is where we've been spending all of our time. I just want to make a comment that I had seen so much Band-Aid approach to the pandemic. And I don't, all I can do is point people to what ASHRAE says. But people are throwing in, UV lights, and they're throwing in the needlepoint ionization, and calling it a day. And I would really recommend that people just look to see what ASHRAE says about those things, because in the end, it appears to me as though ventilation and increasing the amount of outside air is the one thing that is probably going to be the best and healthiest long-term solution. And the reason why I'm saying this, and it's tied to the slide that or the topic I was saying before, is because I believe that the design standards for buildings is going to change. I believe that the COVID-19 pandemic is going to have decades-long influence in how we design our buildings in terms of occupancy and or the HVAC, the size of the HVAC equipment. Because what ASHRAE is saying is that you should open up your outside air as much as you possibly can. Now, in extreme weather, we can't open it up very much. We probably can't go much farther past the minimum ventilation requirements that were designed for design day, especially in a deep winter, polar vortex, that we would get. I'm certain that no building here in Minnesota could have 100% outside air open in a condition like that. And the reason why I'm saying this is because, we have a very agile and easily updated system. Because of the IoT architecture, we can just float updates down to our equipment over the air. Nobody has to run out there with a laptop and connect, a cable to get the equipment updated. So we were able to institute ASHRAE's recommendation for increased ventilation. There's a specific sequence that they detail for a realistic way to get as much outside air as possible. So, on mild days like this, I just did a review of our, of a lot of our buildings, and we do have, very close to 100% outside air going on. in a lot of our portfolio. We have some just great weather, for doing it. And so we feel pretty confident that we're doing the best that we can to follow this guideline and still be realistic in terms of how much outside air a building can actually bring in, given the weather and given the size of the equipment that you're stuck with. Okay, enough on that. So you can go and follow up on all this up at the ASHRAE website. Okay, so I thought that I would follow up with a demonstration of what an IoT type of user interface looks like. It's very different than your traditional BMS. So I'm going to move over to the web for just a minute. This is a web portal that's showing this particular site that I'm showing you is a collection of small buildings that are spread all over the US. That's one of the advantages of a web-enabled supervisor, is that you can get aggregated information for a whole lot of sites and see them in a unified view. So this is Rockler Woodworking. It's a retail chain, and each of these pin drops represents a building. And you can dip into any one of these sites and get information for it. We promised some information about benchmarking and energy analysis. So I just wanted to demonstrate this little part here of this portal. This is a way of showing how much energy is being consumed on a side-by-side basis, one building versus another. This is what's called a terrain graph. And it looks to me like this store at Novi is consuming quite a bit more energy than all of the other stores. This is just showing kWh for today. We can look at any date range. That's the other advantage of an IoT type system. It's all time series data that is stored in big data repositories in the cloud. Far more data than you could ever put onto a workstation located in your building. Now, of course, we want to be smart about that, right? So the system that we have is not dependent on the internet to operate. The internet could go down and it wouldn't make any difference in terms of the actual sequence of operation that the equipment is running. But because we have that link between the cloud and the building, we can replicate all that data up in the cloud and then store it and use it in a much more powerful manner than we would be able to have if we just were storing a little bit of data locally. So yeah, we can go back and look at, say, how much energy was consumed for the month of November. And it would show, a more comprehensive view. So it's going through and calculating and going to demonstrate what we have going on for the month of November. And I can see that for the whole month of November, that store in Novi seems to be consuming more energy than the rest. Now, if we scroll down, we can see that same information presented in other ways. We can show what these buildings are doing in comparison with the benchmark. We can show the time of day in which we have the peak energy use, and we have tabular data, ranking all of the sites in terms of energy consumption, and showing a historical graph, of what's been going on for the month of November. But so how would I use this information? So going back to that view that I did just a minute ago, let's take a look at Novi and figure out, that's what I would do as a sustainability person. I would want to focus my time and attention on equipments, because this could be done by building, or it can be done, like I said here, with multiple sites. But let's just dive into Novi and take a look at what is going on there. Why are they consuming so much more energy than the rest of the stores? So this will give you a chance to see the way a pre-packaged user interface looks. See, that's one of the key differences with an IoT-based system like this. I mentioned earlier that it's all out of the box, so there isn't any front end to develop except for putting this floor plan together. So the way that the front end is presented for one customer is the same that it's presented for all of them, right? So everybody gets the same view. And I can see that in this zone here, this RTU in the middle, the current temperature is 65, is desired to be 71, and I can see that the runtime of this equipment is looking odd. I can tell right away there's something wrong here. So this is the runtime of the unit up here. This is what I meant by time series data, showing what it's doing at this moment is helpful, which is what a lot of BMSs do, but to show it in analytics or in time series, is more helpful. And so this is all just automatically generated and produced. And I can see we're running a lot of heating here, night and day. And I can see that our space temperature is only 65 degrees. So it's very clear that we're trying to heat this space and there's no heater. There's something wrong with this furnace. And we're wasting energy because, we're running that fan, we're trying to heat the space night and day, but nothing's happening without a furnace. And we can look at, any date range to see this. We could go and do an investigation. I'm not going to do it live here. An investigation of when this began. So after this presentation, I'm going to call the facility manager and let him know that you've got trouble with RTU1 at Novi. You're trying to heat the space with a furnace that's not working. So there is an alarm that was generated for this, but I'm sure that many of you understand that an alarm has to be paid attention to and acted on in order to be of any use. So I'm not sure. I think I might spend some time and figure out with the facility manager, how long ago did you get an alarm? What are you doing with your alarms? Did you realize that it actually means something? You're spending more energy here than you really need to. So that completes the sort of prepared part of the presentation. There is a chat feature in your panel over on the right-hand side. If you have any questions for us, would you please just use the chat feature and start, with some questions for me, and we'll try to get to those answers. Meanwhile, Damon, if you or Riley have any questions that have occurred, that have popped up, please just go ahead and start asking those, and we'll see if we can't figure out what people have in mind.
I don't have any questions myself. Look like there's anything at there's no chats right now. So.
Well, you know what that means, Damon? That means the presentation was just so full of information that we answered all possible questions during the presentation, which, as you know, I'm being facetious about that. I'm positive there are questions being generated in people's minds. I see a red thing on the Q&A. Looks like there is a question there. I'm not sure if I can read that. Let's just see.
If you can't, I'll read it for you, Bob, here. Chris Benson said, I believe I was at your site at one point, but will this be sent out to all? Chris, if you're talking about the presentation or the slide deck, Bob, if you're comfortable sending that out, I can send that out to all of our attendees today.
You bet. Yeah.
Also this, great. And also this presentation will be recorded and posted on our blog on our BOMA website. So you guys can find that there too.
I think too, my contact information is in the deck. I know that it's in the deck. So if you end up with a question you kind of wished you asked now, or maybe you're just shy and you don't want to ask that question, you want to ask it privately later, that's fine. I would be happy to answer any questions that come in afterwards through my email or phone.
Perfect. Well, I think that'll do it. Thank you for this, all very excellent information. That was very good. There's a lot to think about there. So thank you, Bob, for providing your expertise on this technology. Hopefully help for our buildings run much more efficiently. And thank you, everybody, for attending. Oh, we got another Q&A, looks like.
Yeah, it looks like I recognize Chris's name. I think we're working on some of his field sites. I think that's true. I'm gonna have to like do a quick research to figure it out. But thank you, Chris. Appreciate that.
Thanks, Bob. Thanks, Damon.
All right, thank you very much.
All right, bye-bye.
Have a good day.
All right, bye-bye.